vector. So my goal in this class is just kind of to get you a toe dip into vectors, give you some context for when you might see them in upper level math classes. So you might see vectors if you take like a Euclidean, like an upper level geometry class. In college, you'll definitely see vectors in the second calculus class that you take. And so I want to give you some, at least just some background info, something to kind of flip back to, because I know you're not going to have a bonfire. You might have a bonfire at the end of the year with some of your notes, but you would never put your pre-calc notes, right? Because they are precious to you forever. In any case, so something for you to flip back to when you know vectors are coming up to give you some context for the math that you're going to be doing. Unit vectors is something that's a very mathy thing. And the thing that's really helpful with unit vectors is they're the same direction as your original vector, but we shrink it down to a magnitude of 1. And shrinking that vector down with that same direction angle can be really helpful if you're doing more complex math with that vector, or if you need to use that vector in a different way. So that's why we do this, is just to shrink it down so it has a magnitude of 1, and in some cases that makes it easier to work with. So we're not going to work with it, we're just doing the math to get a unit vector. So to get a unit vector, we multiply our vector by, well, really we do our vector divided by the magnitude, but what's the easier way to write that equation is this. 1 over your magnitude times your vector. Or what it really looks like is this. Like practically when we write this out. 1 over your magnitude times your vector. And that is not on your equation sheet. So if you're kind of keeping track of what you got on your equation sheet and what you need, that's one that you will need to pull out of your brain at the time of the test. 1 over magnitude times your vector. Sometimes it's nice to see it in words too, especially if you have to memorize it. 1 over magnitude times your original vector. How do we find the magnitude? That is on your equation sheet. Square root of the squares, right? Think Pythagorean theorem. So go ahead and work with the very easy first example. If our vector is negative 3, 4, what's the magnitude? 5, absolutely. So square root of the squares there. So you end up with 25 under that radical, and the square root of that is 5. So that's kind of your pre-work. I like to do that outside of the actual problem. And then I just do unit vector, again, is 1 over my magnitude times my original vector. And I distribute that through. So negative 3/5, 4/5. There's your unit vector. Want to make sure it's a unit vector? I actually used to have this in the notes. If you find the magnitude of this guy, it's 1. So if you do negative 3/5 squared plus negative 4/5 squared and take the square root, you get 1. So that's a way to double check that you really have shrunk your guy down to unit vector. Make sure your magnitude is 1. All right. This next one is kind of trivial. Magnitude, square root of negative 4 plus 0 squared, which is just 4. So 1/4 times -4 is -1. 1/4 times 0 is 0. So we're preserving the direction. So we still have the same direction angle. We still have the same, we're preserving that direction. We're just shrinking that magnitude down to 1. Questions so far? All right, go ahead and bust through the rest of the practice with these next 4 questions. I'll give you a couple minutes, and I'll write answers up. You can double check the work. All right, so this guy, D. So are you okay with the magnitude on D? So we're going to do 1 over 2 radical 5 times our original vector, and that vector is 2, -4. A little room here. So it'd be 2 over 2 radical 5 is my horizontal component, and then -4 over 2 radical 5 is my vertical component. And when I work that, the 2's are going to cancel, so it's going to be 1 over square root of 5. And then you can rationalize. So I'll square root of 5, square root of 5, radical 5 over 5. There's your horizontal. And then your vertical component there, your 4 and your 2 cancel to give you just that -2 on top. And then same thing, you want to rationalize it. Okay, no problem. Any other problems that you want to see middle steps for? Okay. Oh, nice. Oh. Okay, that's a good one. Good question. So we're going to multiply by 1 over 5/2. And 1 over 5/2, that's the same as flipping that guy. So instead of doing 1 over 5/2, I'm going to do 2/5. You okay with that? And then I'm going to multiply that with 1/2 and with square root of 6 over 1. So I think that's the key step, is realizing that when you have 1 over a fraction, that's the same as flipping that fraction. If you're not okay with that, if you need to see another step there, 1 over 1 over 5/2. That becomes your top. The 1 times 2 becomes the numerator, and the 1 times 5 becomes the denominator. Or flip the second and multiply till you're 2. So when you multiply here, you just multiply across. So you get 2 times 1 over 5 times 2, 2 over 10. And same thing here, 2 times radical 6 over 5 times 1. And 2 times 2. That's a little less intuitive. Anything else on this page? 1 over the magnitude times your original vector. Put a little star by it, or a little post-it, or a little flag to remember, to remind yourself to come back and get that in your brain before the quiz next Wednesday. The day before spring break. I and J. Using I and J is very easy. I and J is just a different way to write out your vector. So component form, we have the little kind of triangle-y guys, and we have the horizontal first and the vertical second. Using I and J, your horizontal component is the coefficient of I. Your vertical component is the coefficient of J. Okay, so this will be very easy for us to do with some examples. So we are going to first, so we have u is the unit vector with initial point 3, negative 3, 7, and the terminal point, or sorry, it shouldn't say unit vector there, it should just say vector. Get rid of that. If I didn't get rid of that on your notes. Get rid of the unit vector part right there, and then sorry, I got unit vector happy. So let u be the vector that starts at negative 3, 7 and ends at negative 5, 2. And let v be the vector 3i, negative 2j. So we're going to have to find vector u here in a second, but I just want to use vector v here as an example. 3i, negative 2j is written with that standard form I and j terminology. That is the same as this in component form. So 3 is in front of the I. That tells you that 3 is the horizontal component. Negative 2 is in front of the j. It tells you that negative 2 is the vertical component. The reason that I add this into the unit isn't because that it's hard or even that confusing. But I think that it could be confusing if you've never seen it before and you're in a Calc 2 class in college and all of a sudden your textbook uses I and J's and you've only seen component form. Okay, so just a different way to write the same thing. And totally interchangeable. So the first thing we want to do is find vector u. So from yesterday, we know that the way to find that vector if we're given 2 points, and I'm going to go component form first, is to subtract the last point minus first with our x's. So we're going to do negative 5 minus negative 3. That's going to be our horizontal component. And 2 minus 7 is going to be our vertical. So negative 5 minus negative 3 is negative 2. 2 minus 7 is negative 5. That's component form. To write that in like the I and J standard form, we write negative 2i minus 5j. Does that make sense? Okay, so 5b. So you can work with either form here for v. We just need to end up with i's and j's because that's what our directions say. If you start with 3i minus 2j, you can just distribute the 5 through just like you would in component form. Or you could distribute the 5 through in component form and then change it into i's and j's if you feel like all safe and warm with the little pointy guys. So this is going to give us 5 times 3 is 15i. 5 times negative 2 is 10, negative 10j. That's 5b. 4u minus 5b. So we already found our vector u. I'm just going to stay in the I and J form. Oh, and we found 5b already, I guess. No, this is like a little algebra 1 problem. Distribute. Combine like terms. So negative 8i minus 20j minus 15i plus 10j. Combine your like terms. So negative 23i minus 10J. Did you do my math right? Double check. Questions on I and J?